A machine vision system can be a significant investment, so you need to make sure you get a long-lasting solution for your quality control. This calls for you to build robustness into the solution from the start. Let's take a look at how. Technical robustness in machine vision is about hardware, software, and processes in terms of maintainability. But let's start with the hardware, as this is probably what most people think of when we talk about technical robustness, that the computer will not break down. The durability of a system starts with the choice of components. For example, we always use burn-in tested computers, so we have the best possible assurance that the computer in question can withstand the wear and tear of long-term use. You can't always predict how hardware manufacturers will prioritize their future products, but it's also important to choose hardware where you have the best chance of being able to get spare parts in 5 or 10 years' time. In machine vision, lighting is crucial, and one thing you have to consider is that all light sources lose output over time. You need to consider this in your solution design in several ways. Firstly, it's important to design with plenty of light. For example, by using light sources that provide the desired light, even if they are all only turned up to 50%. That way, there is plenty of room to turn up the light more when the light sources lose output over time. It is also important to design calibration into your solution so that you can continuously ensure that the light can be adjusted to ensure that it still meets the requirements of the given inspection task. Alerts and notifications help ensure that you can react in time. You can design your system to provide alerts if the computer starts to overload, so you can react before it crashes. And you can set up alerts if the light suddenly starts to drift. This is important to catch because when the light drifts, the performance of the vision solution drifts accordingly. Let's turn our attention to the software, because if you want to ensure robustness in your system, it naturally also includes taking into account that the software is fail-safe. One solution may be to install programs whose sole task is to monitor the performance of the other programs and react if something goes wrong. There can be many explanations why a piece of software suddenly fails. But when you have perhaps 15 programs running simultaneously in a machine vision system, you may not necessarily realize that some of your software is failing. If you have a monitoring program running, it can restart programs that are losing performance so that they become healthy and fully functional again. Robustness can also be built into the very analysis that the vision system provides. For example, you can use redundant methods where you inspect the same thing in several different ways or collect too much data and use that to sort out outliers. This makes the system more robust to interfacing factors like dust and vibration. Finally, it's important to emphasize something as practical as maintenance, which should be possible via remote access and documentation of the solution. It is the thorough technical documentation that makes it possible to run service and maintenance on the solution to ensure that it can last for many years.